Hello and welcome everyone to today's webinar, How Trupanion Became an AI-Driven Company for Pets. We're going to get started in about 60 seconds. We still have some folks joining, so if you could stand by for just a few more seconds, we'll kick off very, very shortly. Thank you. All right, we're going to get started, and if you're just now joining, or those who are coming in, you shouldn't miss too much here. So today's webinar, How Trupanion Became an AI-Driven Company for Pets. Looking forward to this talk today. In this role that I deliver a good number of workshops and speeches and stuff. And for the sake of smooth demos, I always use pre-cleaned data sets, demos that are done well beforehand, things like ImageNet, Caltech, something along those lines. That helps facilitate a smooth demo, but it always has a pre-canned feeling or element to it. I love webinars like this today because you're going to hear from the service provider, which is AWS, yours truly, the software vendor, DataRobot, and the end user as well, all three of us in one webinar today. That's Trupanion. And this gives a real genuine real-world use case showing how AI has influenced business processes, or as the title of the webinar goes, How Trupanion Became an AI-Driven Company for Pets. So just a quick second of housekeeping. When you join today's webinar, you selected either join by phone or by computer audio. If you want to choose to switch that at any time during the webinar, just hit the control panel here in the GoToWebinar control panel, and you'll be able to switch to the other option. Also, at the end of today's event, there's a brief survey, so please stay connected when we're all set, or excuse me, when we're all done, and try to fill it out. It's very brief, no problem at all. And then lastly, this presentation is being recorded, and a PowerPoint will be made available to you through SlideShare, along with the recording of the webinar, all via email. So you'll get that very shortly after the webinar wraps up. Okay, so today's speakers, my name is Chris Burns. I'm a senior AI ML solutions architect here at Amazon Web Services, just under 20 years of IT experience. And if you were to summarize my life in a Venn diagram, I would live at the intersection of data scientist, developer, and cloud architect. That's probably all the detail I need to get into today. We have Yong Kim today. He's a customer-facing data scientist from DataRobot. He's one of the wizards that make all this magic happen. And we have Dave Jha from Trupanion. He's also a data scientist. So very happy to be here today and speaking with these gentlemen. I do apologize. I hit forward twice. So for today's agenda, I'm anticipating three general categories of listeners. The data scientist and the aspiring data scientist, as well as developers/architects, and then the hippos. If you don't know what a hippo is, that's a term of endearment. It's not a derogatory comment by any means, and a hippo is the highest paid person's opinion. So what I found in the AI ML ecosystem, if you will, is that we all fall into one of those three categories. Now, I'm going to give a super quick overview of ML, or what we call the AWS ML stack. And then hopefully it's understandable to those three groups of listeners. If you don't fall into one of those three groups, I'll also have an opportunity for Q&A here at the end. Now, I'm not going to speak long. I'm just the opening act. We want to get to the featured machine learning partner, DataRobot, as well as Trupanion, who's going to highlight the case study themselves today. For learning objectives, when it comes to the ML lifecycle, before you decide on a model or even a framework, you have to understand the problem that you want to solve. Once you know the problem, you can begin to evaluate the best strategies for tackling that particular problem. Now, I say that, and I say that in that order because Applied machine learning is difficult, but you don't have to be a data scientist in order to incorporate machine learning into your business processes. So if you're not coming to ML from a DevOps or an architecture background, it could be difficult to get this operationalized. If you are coming to machine learning from a developer or DevOps background, the actual training and inference models could be difficult to train and create. So it's a complex process. It's a journey. It's not a destination, as they like to say. But with tools like DataRobot, you're going to find that allows you to build and deploy predictive models on AWS very quickly without being a data scientist. So hopefully the learning objective of today is you understand that, you see it in a real world use case, and then you can take that back to your own respective businesses and apply that. All right, so machine learning on AWS. Now, Amazon, we've been using machine learning for more than 20 years. Sometimes, excuse me again, it's not readily evident what we've been doing, but even 20 years ago with our very first recommendation engines, we've been using ML in some capacity. I'm not going to dive into these particular points in detail just yet. I got a couple of slides in a few minutes. So I'm going to dive into those in greater detail. The whole point of this is not to be a boring history lesson. I want to set some context so that you know where our ML heritage is coming from and how we've chosen to take our research and our work with ML and make it available to developers. Which brings me to our mission. Our mission here at AWS is very simply put machine learning in the hands of every developer and data scientist. I came to data science myself from a developer role. I was a developer for over a decade before I did anything with what we call the data science realm. So I understand what that journey looks like, and the hard truth of the matter is we can't all be data scientists. So what we're going to see today is we're going to see some tools that's going to help the developers, the DevOps, and the architects achieve ML competencies without being a data scientist themselves. Now, this slide's a little bit salesy for me. I'm a tech guy, so you have to forgive me if I gloss over this very quickly. What this is showing is it's showing 46 billion market by 2020. That's a big number. It's great. What does that mean? The appetite for adopting AI is very spread out. And obviously you see here, it's weighted heavy in the high tech and telecommunications sectors. Now, I want to make sure I'm very clear here. That does not mean that there's more opportunity in the high tech and telecommunication sectors as opposed to down here with healthcare. That just means that the expertise and the resources and time available to implement machine learning processes is greater today in the high tech and telecommunications. That's where most of our data scientists live, our machine learning practitioners. If you're in the healthcare business, you're in the healthcare business for a reason. It's probably not to make inference models. That does not mean to suggest, as I said, that there are not opportunities in healthcare. There's fantastic opportunities in education, healthcare, retail, all of those. This is just where we're seeing trends and patterns in adoption today. One more call out here is that there are 3,000 startups, according to McKinsey, 3,000 up from 100 in 2011. So 30 times more startups today than just a few years ago. And I did it again. If I do that one more time, I apologize. So that heritage of ML at Amazon I was telling you about, this is where I want to dive into a little bit deeper. We have personalized recommendations. And now that's not limited to just recommendations on Amazon.com. Personalized means a lot of different things. It could be health and wellness, where you track disease progression. That's about just as personal as you can possibly get. Financial services are being tailored and customized to individual needs. Advertising, of course, we all know that advertising, the more you target your market, the better, the more effective the advertising is going to be. And also media and branding. Branding is becoming a great big deal with this age of social media. Getting that brand out there is very individualized, very personalized. Now, fulfillment, automation, and inventory management. Our warehouses, shouldn't come as any surprise, use a great deal of automation. That's where we've been able to give the 2-day shipping for free, sometimes same-day shipping for free. And it's really disrupted the idea of purchasing things online. You no longer have to worry about that week ahead of time or even longer lead times when you know that you can get something in just a day or two. That's going to be disrupted even further in the near future when we have our drone fleet. If you've not heard of that yet, Amazon Prime Air is delivery by drones. That's coming soon. Hopefully you've seen some of the videos of the test trials in the UK, and no dates on that just yet. So hopefully we'll see that in the very near future. I'm not going to dive too deep into our voice-driven interactions. I have a couple of slides afterwards to highlight that individually. And the culmination of all this is, Amazon Go store. We have one in Seattle. We're opening one in New York very, very soon. It gives you the ability to walk into the store, take the items you need, and walk back out with nothing more than a smartphone and an app. There's no self-checkout kiosk. There's no cashiers. It's disrupting the customer user interface to the retail chain, and it's really creating entirely new customer experiences. So Alexa, and I meant to say the Echo family. If I kicked off your Alexa in the background, I apologize. I'll call it the Echo from now on. The Echo family of products, we have the Echo Show, we have the classic Echo, the Spot, we have the Look, quite a few options now in that line of products. And it really all revolves around voice-driven interactions. So it's really, again, I'm going to use the word disruption. It's changing the interface with how we interact with some of our systems, whether that's home automation or even our Alexa for Business line of products. Just as a personal anecdote, we recently moved into a new home, and I've put Echo spots in every room. If you have kids, hopefully you can sympathize with me when I'm on one story of the home and I hear a big crash on another story of the home. I know something is going awry, so I just drop in now with those Echo spots and survey the damage that my kids are wreaking without having to go up the stairs. So just a quick silly example of one of the things you can do with that Echo. Now, I also mentioned the Echo Show and the Echo Spot, which is beginning to incorporate video into the NLP algorithms that we have there. So Amazon Recognition Video is a service. There's no learning required. This is a service that's already been trained. You simply send your video or your image to that service for analysis over a clean JSON API, and you get back a lot of great information. It all really depends on what you ask for. We have a number of services from object and activity detection. Now, the activity, we're going to get to that in a minute. That's an important nuance, activity detection, all the way to celebrity recognition. If you've ever watched an Amazon Fire TV and paused it, and you get the actors and actresses popped up on the bottom of the screen, that's leveraging recognition video, and it's also leveraging the acquisition of the IMDb database by Amazon. So here's a still from a video that we sent to Recognition Video, and the labels here are authentic. So obviously it's a stage scene, but this video, the labels are authentic. We see balloon, we see gift, we see child, and what Recognition is able to infer on top of the object detection is that this is a party. If we were to take a picture of a kitchen, it would identify certain appliances. It would put 2 and 2 together and say, hey, this is a kitchen. Same with the living room, same with its indoors, same with its outdoors. So that's a level of understanding that is very important. I want to make sure I draw that distinction, because we're inferring events and we're going beyond object detection. So can't wait to see what's next on that horizon. So I'm a quick time check. I'm a little bit over here, so I'm going to go quickly. This is a kind of, the Amazon machine learning stack, as we like to call it. Top level application services. This is where I'm going to address the developers. If you're a developer and you want to incorporate text to speech or speech to text or translation or transcription or sentiment analysis, this is where you go. These are services pre-built. All you do is call via API, you get the input, output, and you go about your business. You get you're gonna infuse AI into your applications in as soon as an afternoon. So down in the second layer, we have platform services. If you are running a data scientist team, or if you're a developer that want to train your own models, we have Amazon SageMaker. That's an application that handles end-to-end training, deployment, and hosting of inference models. It does a great job of connecting your data scientists with your developers in your ops department. AWS DPlans, a smart camera that's going to be available to you next month. We've taken a camera, added some intelligence to that, and along with SageMaker, we can now push models with a single click, inference models to that DPlans. So if you want to do object detection of a customized type, or I have a couple of DPlenses on a robot I use for auto navigation. So a lot of opportunity, a lot of opportunity there to use DPlans for object detection. Also, we have Amazon Spark and EMR. If you're a classic Hadoop shop and you want that single source of truth for your data, you can attach SageMaker to a Spark EMR cluster, or you can use the customized Spark and EMRs that we have available. And then finally, Mechanical Turk. That's here because it's critical. If you have a data set, let's say it's an image data set, and you've got 1 million images, and you need to do some supervised learning, you have to label those images. I don't know if you've ever tried to label 1 million images, but I don't recommend it. So that's a perfect job for a Mechanical Turk. You spin up a job, you put some criteria around what the images are, what the categories are, and you let it go to town for you. And then finally, we have our frameworks and our infrastructure. Training can be a complex process. I've seen jobs go with fleets of P3s, fleets of GPUs for multiple days. I've seen terabyte workloads process on these P3s that just 2-3 years ago would have taken months. So we have the hardware that you need to train any model that you want to use on any framework that you want to use, which brings you to one of my last points here. We don't push you towards one particular framework or the other. We are about building blocks. You bring the tools that you want to work with to the environment, and you go about your business there. All right, a couple of logos for you. Perhaps you'll recognize one or two of these. These are all customers running machine learning workloads on AWS today. And then finally, before I hand it off to Yong Kim of DataRobot, I want to just 30 seconds touch on our machine learning competency. If you're familiar with AWS, you know we have multiple competencies. This is a level of certification that we give to choice partners who have demonstrated an aptitude in a particular field. We have this for Windows migration. We have this for big data, a number of different fields. Recently, we launched the machine learning competency. And DataRobot, I'm happy to announce, is one of those machine learning competency partners, which again certifies that they know what they're doing, they do it well, and you can trust them with your data and your business processes. So with that, I do apologize for that a million miles an hour spiel. I'll have opportunity for Q&A at the end today, so get your questions in there as we're speaking. I'll hand it off to Yong Kim, data scientist with DataRobot.
Great, thank you, Chris, and thank you AWS for hosting us. I'm excited to present, give a quick demo, an overview of DataRobot. Advance the slides here. So as Chris mentioned, I'm a customer-facing data scientist, and what that means is that I'm an outdoor data scientist. I'm out in the field, in the trenches, working with enterprises, big and small, to help them implement machine learning within their organization. And the typical experience, this is what the customers that I work with are experiencing today when it comes to AI or machine learning, that machine learning is too hard, it's too manual, and too exclusive. And the problem really is not about lack of tools or even cost, because there's lots of open source and free tools that are out there, but it's really about expertise. And so what DataRobot is about is that we're really innovating, bringing innovation to machine learning and data science and AI through automation. So it's automation that allows teams of experienced data scientists to scale, but also it's automation that allows teams of developers, business analysts, those who are not traditional data scientists, to actually build models very confidently that would meet or exceed the quality and the scrutiny of models built by experienced data scientists. And so when you look at the data science workflows, this is what you're paying your data scientists to do today, right? Apart from the data engineering, data gathering, but this is where you're going to need data science expertise for data pre-processing and feature engineering, running diverse set of algorithms, benchmarking, train tuning and testing, ensembling, documenting even, right? So this is what you're going to see today, how we've automated that with a quick start of a button. So let me switch over and share my screen. And let me know if you can. Great. I'm going to share my screen. And we start with the data set. So the demo I'm going to walk you through, we'll use a real life demo from a hospital EMR system. So the idea here is, can we predict which patients are going to be readmitted back to the hospital or not, so you can prevent that or reduce the chances of that. So this is a typical data set that you would use for any machine learning application. So it has, each record represents a patient, but each column, the features, represent some attribute about the patient, right? Three things I want to call out. This data set consists of categorical variables, numeric variables, as well as text data. So this is free-form text. Also, there's some messiness to this data. Some missing information is encoded as question mark or blank. So this requires, even though the data set looks ready for machine learning, from a data science perspective, there's still lots of expertise required to normalize numeric data, look at the distributions. How are you going to handle these categorical when there's lots of levels? How do you clean up the missing and so on? So this is where DataRobot automation is super helpful. I'm going to walk you through how DataRobot then makes the modeling process super easy. So this is running on our AWS instance. A lot of our customers actually leverage our AWS instance to get started, but also DataRobot can be deployed on premises on your own hardware or a VPC situation. So from a workflow perspective, it's as simple as just dragging and dropping the data. But you notice we have connectors built into data residing in a relational database or S3 bucket or Hadoop, but it's as simple as just loading the data onto the platform. Now, everything I'm going to show you through the UI. But all this can also be done, if you're a developer familiar with Python or R, everything I'm going to show you can be actually done through scripting in Python and R as well. We have APIs that you can access as well. So the automation starts here. As we're loading the data, DataRobot has automatically done some initial exploratory data analysis and will bring you back to visualization. So once the data is loaded, if I scroll down, what you see is the summary statistics. And then if you click on any of these variables, you can see the distribution and so on. So you're just doing some quick sanity check. But the step one here is to identify what are you trying to predict? What is the target variable? In this case, it's called be admitted. And that's it. DataRobot is ready to start modeling. At this point, you can just press start. But the reason why you can confidently press start is because we've already, under the hood, put in some guardrails, standard best practices for building good machine learning models. So things like feature lists and optimization metrics are selected for you. But all these are can be overridden. So although we focus on automation, it's not automation only. So if you're an advanced data scientist and want to have control over how to set up a validation framework and so on, it's fully controllable to you as well. And this is the reason why. It's because of the safeguards that we've put in place that anybody can just press start and start building models. So when we press start, what DataRobot is doing then is looking through the data in its entirety once more, and it's actually constructing a workflow that a data scientist might create. So the workflow consists of both the pre-processing and the feature engineering step, as well as actually selecting the right algorithms and training and tuning those algorithms for you automatically. So on the right, what you're seeing is it's putting together all these workflows, and once it's done, it'll start executing the training. So that's what's happening here and to the right. So what you'll notice here are a couple of things. Number one, without having to write a single line of code, DataRobot is actually running algorithms from multiple libraries like Python, scikit-learn, linear, nonlinear type of algorithms, right? So I'm scrolling down this list here of all the ones that are in the queue to be trained. There's R-based algorithms. Some of these are DataRobot specific implementations of some of these methodologies. You'll notice we have TensorFlow, XGBoost, Valpo-Wabbit, LightGBM, which was recently released by Microsoft. So all these algorithms are running along with the appropriate pre-processing steps, and all that without having to write a single line of code. Now, what I want to highlight here is the ability to actually leverage the worker resources, compute resources that you have on AWS. So I just cranked this up to 20 workers, 20 compute resources, so that I can run these models in parallel across 20 machines, essentially. So it's really easy to leverage the parallel computing capability here. And then what happens is, as these models get finished building, I'm going to switch over to the models tab. So what we're showing you here is this is a leaderboard that ranks dynamically the models based on their accuracy. So we're going to actually do several rounds of modeling in this process and get you to the best one as quickly as possible. So automation is great, but I think a lot of the criticism around some of these techniques is that a lot of it is black box. And this is where I want to actually address in the next few minutes here. So black box, typically, when you talk about black box, what people usually mean are you don't know how these models are built. Also, it's hard to interpret or gain insights from these models. And what makes DataRobot so unique in this space is that we actually have spent a lot of time and effort to address that concern. And that's what I'm going to show you today in the rest of the demo. I'm going to walk you through how do you understand and how do you derive insights and put these models to production very quickly? This is like a cooking show. I'm going to take you to a project with the same data set that's finished. So this is the finished leaderboard. On top of the leaderboard, you have models that are combinations of other models. So this ENet blender automatically is a combination of individual models together, and typically they perform very well. So now let's talk about how did we build these models. So the first thing you'll do is click on any of the models on the leaderboard, and then the first thing you'll see is this, what we call a blueprint. So a blueprint is a visual representation of the data science workflow that DataRobot is following. So each of these boxes represent the pre-processing steps that DataRobot has followed. And then here, this box represents the actual training. If I click on a box, let's say you're not as familiar with what an XGBoost algorithm does, just click on a box and we'll take you to the documentation so you can read about the algorithms, read about the hyperparameters, things that you can control, and then we give you links to the code. These are open source code that we've implemented, and then some academic literature as well. So if you're new to machine learning, this is just a great way to get started and kind of learn how machine learning is done and some of the theory behind it as well. So you notice that automatically DataRobot has built out these workflows for you across lots of different algorithms, right? Typically, second thing you want to know is once you understand how these models are built, how well do they perform? So we do have, very quickly, I'm going to show you standard metrics like list charts and ROC curves, all out of the box generated for you, and you can export these as well. But to me, the more interesting thing is around interpretability and insight. So oftentimes when you build a model, the business question is, well, what are the drivers of risk in terms of readmission? So this, what we call feature impact, shows you for any model on the leaderboard, it can show you exactly how each of the variables impact the score or the accuracy of your model. So the most important variable here is number of inpatient visits, medical specialty, diagnosis, and the description itself is very useful as well, right? So this shows you, again, what are the most relevant drivers of risk. Also, we can actually explain the directional relationship of these variables using what we call model X-ray. A technical term for this is partial dependence plots. So it shows you as number of patients increase, how does that impact the readmission risk, right? And then last thing I want to show here is this ability to explain at the prediction level what's specific about the patient in this case that's driving their score. So this patient has a 93% chance of readmission. It's because their weight, they have a high number of inpatient visits and a couple of outpatient visits that's driving their particular score to be very high risk of readmission. Right? So this level of understanding, I think it's fairly unique to DataRobot and makes it really approachable and consumable to the end users of the models. Lastly, what I want to show you is how do you put these models into production? And it's really simple. So we're going to just move over to predict. You can either drag and drop a new data set and compute using the UI, or a lot of our customers actually leverage our prediction API. So the idea here is that all the models that we build, you can create a API endpoint so that you can just access it from any web application or any other application by just calling the API. So here's actually a live code that you can just simply cut and paste. We've already pre-populated the API token, the project ID, and then you're just calling the endpoint here, and then loading a single record or batch of records, so to support real-time or batch predictions. And then if you wanted to deploy this using code, we do support that. But actually, the last thing I want to show is this compliance documentation. Oftentimes, we work with customers that are in very highly regulated industries like banks and insurance companies, and we work with regulators and banks to come up with a documentation that really explains the modeling process that they care about. So you can, any of these models, you can generate this model documentation, and then just a quick overview. This is a 26-page document that was created. The blue areas are what the individual users would populate, but we've basically pre-populated. We've done pretty much 80% of the work here by providing all the documentation necessary to display or to share with the regulator to show exactly what's been done. So with that, I'm going to stop here and we'll take questions later and hand it over to David.
All right, thank you, Young, and thank you to AWS for inviting me to talk through our use case. Here we go. Hello, everyone. My name is Dave. I lead the data science team here at Trupanion. We provide medical insurance for cats and dogs. Tiny bit about myself. My background is actually in mechanical engineering. That's where my schooling is in, and I first was exposed to machine learning in graduate school many, many years ago. And I've been doing related type work ever since. Okay. Over this talk, I'm going to show you guys like a real world use case of how this stuff is actually applied. But before getting into that, I wanted to give you guys a little bit of background on our actual, oops, not clicked on it, on the actual industry. So many of you may not be experts in in pet insurance. So a little bit about the company. Trupanion, we are based in Seattle. We have a little over 500 employees and 400,000 policyholders, members, with 250 million in annual revenue. Something that's not listed here, which I find interesting, is that in the US and Canada, we only have about 1% of penetration. So only 1 out of 100 pets have pet insurance. Now, compare that to countries in Northern Europe, like Sweden or the UK. They have upwards of 25, maybe 35% penetration. So we're in a very largely underpenetrated market, and every 1% of penetration in our market in North America equates to about $1 billion in annual revenue. So big upside, big potential for growth. You'll see in the picture that's a fairly standard workstation here at our office. You'll see a kitty cat sitting in a bed with just monitors and keyboards everywhere. And that's kind of our office. It's really fun. About 150 dogs show up on any given day in our office. So pretty hectic and pretty fun. All right, more background information. I'm a part of the data science team is a part of a larger team, which we call analytics. And we're a centralized department, meaning that every piece of the company that needs, let's say, reporting or ad hoc analyses or kind of guidance, like data-driven guidance, they come to our team and our team only, meaning they don't really hire business analysts for their own departments. And I find that that has been a very big advantage in pushing projects through. Over the years, we've built up very deep and meaningful relationships. We've built up a good reputation with all of our customers. And as you can imagine, pushing projects through when the relationships with the end users are good is much easier than pushing a project through, say, contrasted with a siloed data science department. Probably a very obvious point to many of the listeners, but not obvious to maybe someone like me who spends most of their time writing code. Cool. All right, so finally, let's get to the meat of the presentation. What I'm going to talk to you guys about is automating claims. So additional background information. If you're not familiar with the industry, then you may not be familiar with how claims are submitted. So let's say you take your pet to the veterinarian and veterinarian, let's say gets an exam or gives them an exam and prescribes some medication. Well, if you have pet insurance or pet health insurance, what you would do is a very typical process would be the receptionist prints you out an invoice, like a literal piece of paper invoice. And you would either take a picture with your camera and email it into us, or even scan it and fax it into us. So a very clunky process. Okay. Once we then receive the invoice, it's fairly standard for the turnaround time to be upwards of a week or even 2 weeks, right? Someone has to receive the invoice and kind of get it in the format that we're used to adjudicating it in. And a couple of differences here. So in that long and clunky process, it's difficult to improve. It's kind of like a dead end. It's really difficult to put any sort of automation on that because we have the really difficult barrier of optical character recognition, right? And what that means is using computer vision, like the computer will actually go through and pick out the text, what it exactly says, because we just receive it as a picture, right? If you take a picture with your camera and send it in, it's a PDF, right? So we have to go through this really arduous process we would have to go through this arduous process of picking out the text and, what dollar amount it corresponds to and what of the text is actual invoice line items and what is like information, like an address that we don't actually care about, stuff like that. So what makes our position unique is that we've invested in building our homegrown software called Trupanion Express. And Trupanion Express actually is installed on the veterinarian side, and it comes with a lot of attractive features that improve their workflow. But the feature that's most important, that's critical to us, is that when they submit a claim and they have Trupanion Express, we actually receive the text data, the raw data. So rather than getting a photo, a picture, we're getting what the pet, which pet they're submitting it for, along with exactly what was prescribed, which procedure was done, what the date was. We don't have to do optical character recognition, and it becomes a fairly traditional text analysis problem. Okay, so that's a barrier that had to be kind of overcome before any machine learning and any projects were kind of written up and proved out. Not to cheapen, not to make it sound like super easy. Once you have the text problem, then you can do anything. That's not necessarily true. I think it's fair to say that veterinary medicine is kind of like the wild, wild west compared to human medicine. There's no such thing as standardized diagnoses codes. So we have to like figure out, or not we, but the machine learning algorithms have to figure out which medications go to which types of medical conditions and which types of operations are only for certain illnesses. So on. And a lot of them are simple. We do run into cases where this specific procedure or this specific type of medication treats and only treats one thing. So that's a pretty straightforward text classification problem. However, there are instances where it's just as if your doctor prescribed you like Tylenol or NSAIDs. That could treat anything, and those types of scenarios require a little bit more creative problem solving. Cool. That's all I want to cover on this side. All right, and finally, I wanted to talk to you guys about this project going from just kind of idea conception to prototyping and finally through to production. So when this was just an idea, there was, I guess, how our method of operation here is not all ideas become projects, right? And not all projects go into production. That's probably fairly standard across the industry. But with the help of DataRobot and kind of our discipline of proving out return on investment before moving forward, it's really our first swing at it had to be very rapid, right? I had to just really figure out whether or not the accuracy is there to kind of prove that my models were good enough to be actionable, right? If let's say we're only 80% accurate, 1 out of 5 claims we're making a mistake, that's just not good enough, right? So the picture on the left is kind of a very black box. I just toss everything at this machine learning model. Much of it was done in DataRobot, and I get out an answer like, is this a pay or deny? And once that crosses a threshold, like our threshold happened to be where we need to be 99% accurate in, let's say, 10% of claims that come in. That's when we got the green light to, add resources to the project as well as work on a better architecture. Okay, and that brings us to the picture on the right, the one that has more blocks. So this is, I don't really want to get into the details, but maybe my takeaway for you guys is to just know that the important transition from prototype to production was, rather than have one big box, one big black box that takes all of the information that a human claims adjuster would, use, and then just shove it through an algorithm and get an answer out. We break that black box into very distinct, smaller boxes. So it's almost always a good idea to break, big, complicated problems into smaller, more manageable pieces. That's exactly what we've done. So every smaller box in the middle denies a claim for a very specific reason, right? These are policy exclusions. We just don't cover squeaky toys. We don't cover pre-existing conditions. And if any one of those boxes detects a reason to deny the claim, we deny the claim. If an invoice gets through, kind of runs the gauntlet of all these boxes, and we can't figure out a reason to deny it, then we pay the claim, right? And a lot of advantages to this architecture. The one disadvantage is that it's clunkier, right? We have more models rather than one end-all model. We have 15 tiny ones. Lots of advantages to offset, right? If every model is independent, then we could process them in parallel, right? And really just reduce the runtime. So now I think we went from something like 90 seconds for the prototype model to churn out an answer on an invoice. We're down to close to 10 seconds. As well as it's just easier to maintain. It's easier for multiple people to work in independent models rather than overlapping work. And I almost forgot, the most important point is that it's actually in production. Like when I was asked to do this webinar, it wasn't actually deployed yet, but a few weeks ago, it's deployed and it's in production, and people with Trupanion policies going into vet offices are submitting claims and they're getting answers within 10 seconds. And I think we've done hundreds of claims in the last few weeks and only made 3 errors. So we're doing pretty well, which I'm glad to report. That could have gone very differently. All right. Okay, so this project has obvious impacts, right? Obvious operational savings. Rather than having people with hands on keyboards, it's just getting churned through. Better customer experience is the big one, right? If you're going down from a week to a couple seconds, then I think it's fair to say that going to the veterinarian, getting a big invoice, let's say it's like $10,000 or something like that, you mail it into your insurance company, you hope they cover it, you don't know if they cover it until a week later, right? Terrible experience. Knowing within 10 seconds is much improved. And our dream or our mission as a company is to, if you were to picture the situation where your pet is very sick, you take your pet in and the vet tells you that needs an operation. This operation is going to cost $5,000 or $10,000, and you need to make a decision on the spot. Am I going to fork over, write a check for 10 grand, or am I going to leave the office without my pet? Terrible, right? That should never ever happen. And in order for us to get to the state where that doesn't happen anymore, the claims process has to be closer to human health, right? It has to just be a sure thing. And I think this project gets us closer. Yeah. And non-obvious point is it's a better experience for our employees as well. I mentioned earlier we're starting out with 10-15% automation. Those claims being automated are the easy claims, the ones that are just obvious pays or obvious denies. Our claims team is filled with people with actual technical medical expertise, and the claims that's left over for them actually activates that information and are the challenging ones that are interesting, right? So it's better all around. All right, last slide before we get to Q&A. DataRobot has both DataRobot and AWS has really enabled us to do this with a fairly lean team. For a very long time, it was just me doing this, and recently we added a second data scientist. And so I don't think I mentioned this, but every one of those models, those 15 models, is sitting on a AWS instance. So it's in the cloud and it's just serving 24/7. Before getting there, DataRobot does really enable us to just model quickly and prove out ROI that will for sure inform our decision making. Yang mentioned that there's a big expertise gap, and I wanted to add on to that. Not only does DataRobot let's say, more of the analyst type without knowledge of coding, push models to production, and that's definitely true. But also, even those with the expertise to apply models, that's not fun. It's not fun to tune hyperparameters. It's tedious. So it really lets us focus on the things that are larger impact, things that require, that activates the parts of our brain, like a creativity. Like the creative problem solving is not tuning how deep your tree goes. It's more of kind of deciphering. In our case, we're kind of deciphering the human decision-making process. Yeah, so good all around. Right, I think I covered all these points, and I think this is a good time to move to Q&A. Thank you.
All right, thanks, David. This is Chris Beck. I do apologize. It helps to take the mic off of mute when I want to talk to the audience. So let's see. We got a few questions here. We can dig into those. And if you have not yet submitted a question, you still have some time. To do so. And it looks like the first one is going to go to DataRobot. And the gentleman asks, apologize, one second. I got to. All right, first he offers up a thank you for referencing the black box issue with machine learning. And it's always a challenge to implement an ML tool such as this. It looks like DataRobot tries to address this. He says, for example, the example with wait for hospital visits, that's not a wait time, that's a patient wait. How do you derive patient wait as the factor? So, Yang, I guess what we could talk about here for a moment is we're kind of dipping our toe into the realm of feature engineering, and how do we know that that's a category that we want to use when modeling against patients in a hospital stay? So, do you want to add some color to that?
Yes, thank you for that. So typically what you want to do as you're prototyping, as David mentioned, is oftentimes you don't know which features are going to work or are going to be predictive or not. So you start with a very large set of features. And I've seen business problems where there are thousands of features for credit modeling and things like that. So what DataRobot allows you to do is then just throw all those features at it and let the machine learning algorithms figure out the most important variables that have impact. But also, it's not just about the raw features themselves. What DataRobot will do is look for interactions. Also, there's ways to bin numerical data to capture nonlinearities and things like that. So these are the kinds of techniques that an experienced data scientist would know how to do. But with DataRobot, you get that out of the box. That level of expertise already is built in, so that we will apply sort of the best practice for handling numeric categorical text features for you. And then we will show you the results after the feature engineering has been done, right? Hopefully that answers that question. But if you have questions more, if you'd like to go deeper, please reach out to me, and love to have that conversation, maybe at a deeper level as well.
All right, great. Thanks, Young. I think a lot of these are they're great questions, but they could be turned into a conversation in and of themselves. So I'll take another one here. Another one is it's addressing the time-tested issue of missing data. So how do you handle missing data? And I'll take a quick stab, Yong, and then I guess you can probably correct me. But I've seen two fundamental approaches to missing data. One is you exclude any records or any observations, excuse me, that have null values, or you try to take a standard deviation and you try to plug in a mean there, which gives you a very vanilla value, which probably means it's not going to really influence the outcomes dramatically, but it could be mistaken there. So it really all depends on the other complementary features that you have in that data set. So those are the two use cases I've seen predominantly with missing data. But Yong, you want to take a swipe at that one?
Sure. Yeah. With missing data, there's a couple of things that you want to know, right? Is it missing completely at random, MCAR, or is it systematically missing? So those are the kinds of domain expertise that you're going to might be helpful. But with DataRobot, practically how we can deal with how DataRobot deals with missing data is this. First of all, are these variables important enough where doing some sort of missing value imputation is going to be helpful or not, right? So that's one thing. So in no sense working and cleaning missing data if it's not really helpful to the model. So you can quickly iterate. Also, what DataRobot will do is automatically do some missing value imputation. So if you look at those blueprints a little more detailed, you can see what DataRobot does in terms of how it does its missing value imputation. So again, depending on if it's a numeric value that's missing or a categorical value that's missing, you're going to try to treat that differently, but DataRobot will do that automatically for you.
All right, great. So here's one for Dave. Excuse me, an attendee would like to know how big was the data set for fitting the 15 models that you trained for Trupanion. So I guess when they say how big was the data set, let's just go for, I guess, volume. And then if you have a rough estimate of record count, maybe we can offer them both.
Yeah, that's a great question. Trying to think of the question behind the question. So we started deploying the software, I want to say around 2014, and we started building these models maybe mid 2016. And if I remember correctly, the record count was somewhere around 250,000 records for a straight pay deny. That's a binary model, right? And I think in our case, 250K was enough. However, there was the case of, so I previously alluded to the problem of not having standardized diagnosis codes. So that one is tricky because it's not a simple binary model. This is a model with thousands of different classes. Like, is it an allergy? Is it a limping? Is it an ACL tear? So on. The list goes on and on. And for that one, we had to really get creative with how we prepared the training set. So this is kind of a rule of thumb. I think many data scientists would agree. If you have 5,000 classes and you only have 200,000 training samples, it's probably not enough. So we had to get creative and kind of synthesize our own data set. So to answer your question, it varies widely to what part of the model you're talking about, but let's say somewhere between 200,000 and 1 million training samples would be a fair answer. That's the ballpark.
All right, thanks, Dave. That should take care of the hopefully that's the information that they were looking for there. So looks like I got another one for you, Dave. So the question is, given your success with DataRobot and this great project, what do you have any quick tips and tricks about pitfalls you may have encountered during the learning process that you could pass on to the listeners? It looks like it's from a kindred animal spirit. Animal Friends UK is where that question is coming from.
Perfect. Glad you could join us from across the pond. Pitfalls we encountered. gosh, there were a lot of pitfalls. So one thing that I am thankful for is that here at Trupanion, we really are a data-driven company. Like every decision, every piece of information that drives the decision that a claims adjuster makes is documented somewhere. I said every. I meant to say almost every. So for the pieces of missing information that maybe they read off a document or maybe they got from a phone call, something that I can't see, every one of those is potential to be a showstopper, right? And and every one requires a unique solution. I guess the answer is just don't give up. When things look grim, don't give up. I guess eventually you would have to give up. I guess not really trusting the textbook. There's much more to building successful models than what you can learn from a Google article, right? A lot of it comes from subject matter expertise. That's the answer. You have to really just work very closely with someone who really understands the data, and that's exactly what we did. We found a really bright individual who used to work in the claims department, and we just kind of stole him from that department and added him to our team. But I worked very closely with him to understand the oddities in the data, right? Things that are just not intuitive, and we've broken through several barriers just with acquiring the help of a subject matter expert.
All right, great. Thanks, David. So I think we got time for one more here, and I was doing two things at once, and I just lost it. And it looks like there's going to be a question for DataRobot, and it looks like it's an operational question, and it says, I'm sorry, the questions are coming in pretty quick, and it's just moved on me. It says, can DataRobot inject this info real time to inform staff of potential at-risk patients while under their care? And so, Young, I'll let you take a swipe at that. I could add a bit of color myself afterwards if you want. Otherwise, I'll let you take first stab at that one.
Sure. Yeah. Thank you. Yes. So a lot of our customers do real-time predictions, and that's where the API, the RESTful API service for these models is quite useful, right? So I've actually been part of actually building out a readmission app that does real-time scoring. So I've seen that work. But yes, you can do real-time scoring. A lot of our customers do real-time scoring as well. So we just make it really easy to do that through by exposing these models as a REST endpoint.
All right, thanks. I don't need to add much to that. I'll just restate, sort of summarizing here, Machine Learning 101 is that the training process, very tedious, very time consuming, very detail oriented, can really take up probably 80–90% of your time. But once you get to the inference stage and you have that API, you simply integrate that into your business process, and it goes at the speed of your business process. And whether you want to call that real time or near real time is entirely up to you. So if you were to have a facility with an inference model running in production, that you could incorporate that into a decision-making process there in the actual production, then you're going to get really, really close to real time. So hopefully that took care of that question. I think we got time for one more. I'm gonna stuff one more in here. Sorry, I need to mark these better. Okay, so this is kind of a loaded question. I'll actually offer up an answer first. To have good results in DataRobot, how much historical data time do I need to have? So really, that's the $100,000 question when it comes to machine learning is, how many observations do you need in order to get an accurate inference? And it's very situational. It's very circumstantial. If you're dealing with image text, I've encountered professionals who turn their nose at anything less than 10,000 observations of each category. So if, for instance, if you wanted to identify cats and dogs, they wanted 10,000 pictures of a cat. But sometimes you can drive that number down to even less than 1,000. So really, it's going to depend on what you're trying to do there. I'll give Yong here the last 60 seconds to add a little bit of color to that.
Yeah, thank you. That's a very good question, actually. So practically, from DataRobot perspective, what we recommend is, look, if you, no sense trying to train something 100 gigabytes of data when you could have done so with a 1 gigabyte. You find that it doesn't really have any, provide you any lift, right? So our philosophy and what we've advocated always been is start with something manageable, reasonable, that you can get your arms around quickly and iterate fast and see where you're at. And we actually have screen or tools, visualizations within our platform that will show you exactly, as you increase more data, do you get more accuracy, or at some point does these algorithms actually flatten out? So yeah, we actually can show you what is the right amount of data that you should be working with as well.
All right, great. So we're going to conclude there, folks. Thank you very much for taking the time today. We understand how hard it is to get some free time in the middle of the day to attend a webinar such as this. So if there's more information at these links, if you want to hit those links at any time, and actually I'll even offer up my own email address. It's my last name, Burns, CA, at Amazon.com. So if you did submit a question I didn't get to you, I do apologize. You can feel free to send me an email. You can reach out to any of us here at these links, and we'll hopefully get the information that you need. So again, thank you for your time today, and thank you to the speakers.
Thank you.